All right, so this last lesson before your guys' quiz is just now pretty much a bunch of different other ways that you can represent data to analyze what we're looking at. So we talked so far about box and whisker plots and histograms. Now we're going to be talking about several other methods. And so the first one is a bar graph, which you guys, have been really looking at since probably kindergarten, so I can move through this one pretty quickly. So bar graphs are usually used to represent like what's called qualitative, or sometimes you'll see this called categorical data. So qualitative data cannot be measured. Like you can't find the mean, the median, or the mode of data like this. It's kind of broken down into like categories. So when you're looking at what's most popular, what's least popular, things like that. And so when we're looking at how many responses are represented by this graph, this is now kind of similar to what we did with histograms. So you've got your labels on the x-axis, you've got your totals on the y-axis. We're looking at favorite type of movie here. So we would just add up all of these bars. So 4 plus 5 plus 6 plus 1 plus 4 is 20. And so then how many more responses named comedy as opposed to drama? Well, there were 4 comedies, 1 drama, so that would be 3. And then the most popular type of movie is obviously going to be the highest bar, so that would be romance. People love a good romance movie. Okay, that's really all there is to bar graph, guys. All right, so the next one we're going to look at is called a scatter plot. So a scatter plot is used to plot specific data points from a data set to show the relationship between the two variables. And that relationship that we're looking for is called the correlation. Okay, there are 3 types of correlation: positive, negative, or none. So a positive correlation means as one variable increases, so does the other. So because we're graphing these, we're kind of looking for what the slopes of the line of best fit would be. So if it's a positive correlation, you'd have a positive slope. If you had a negative correlation, your slope would be negative. It means as one variable gets bigger, the other one gets smaller. And then if there's no correlation, that means that after you plot all of your points, your data is going to be kind of like all spread out like that. So there's not really any relationship between the two variables. For example, like I think about if I were to plot like hair color and how fast you can run a mile, so if I were to plot hair color on the x-axis and how fast you can run a mile on the y-axis, there's probably no correlation between those two values. Okay, all right, so we're going to look at 2 examples. This first one right here is about distance and rent. So if you're ever making a scatter plot, just like we've been talking about, make sure your axes are always labeled, all your intervals should be even, etc. All right, and so what we can kind of see here before we answer these questions is we're looking at how far you are from the city in miles and how much you're paying for your rent. So if you are 0 miles from the city, so if you live in the city, your rent is the highest. And as you move farther away, it looks like the rent is getting smaller, right? The smallest value right here is about 9 miles from the city. We're paying a little bit less than $600 for rent. It's a significant change right here. So it's definitely more cost effective to live farther away from the city because the cost is decreasing as the mileage is increasing. And so when you're asked another question like this, what is the approximate cost when you live 4 miles from the city? So here's our miles. I'm just going to go up and find that corresponding point. So I'm going to say if this is 700 This is maybe about $750. Okay. And so if we were to draw a line of best fit, which is a line that kind of is close to all of your data points right here, since that has a negative slope, that means that we have a negative correlation. So as the distance is increasing, the cost is decreasing. All right, this next one is about beach visitors. So our x-axis represents the average daily temperature in degrees Fahrenheit, and this is how many visitors the beach recorded. Okay. And so if I want to find the median number of visitors to the beach, what we want to do, and you can do this in one of two ways. You could either, because again, we're looking at this, so kind of going up here, because that's going to be your data in order, and then kind of go in and find the median this way. It's going to be a little bit faster if you kind of do that more conceptually. And that goes back to understanding what the median value is going to be. So the first thing that I'm going to do is count how many points were plotted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so if I think about what value would be the median, 11 divided by 2 is 5.5. So that means that the sixth value will be the median. Because then that 6, we would draw our line through that, and you'd have 5 values on this side, 5 values on this side to get 10, and then that sixth value would be the median. Oops. So what I'm going to do now is just start down here, and I am going to work my way up to that sixth highest point, and that is going to be the median number of visitors. So this would have been my smallest number of visitors. Then this would have been my next one. So there's 2, 3, 4, 5, and then either one of these 450s would be my sixth, because I'd have 2 of those values in my list, so that would be my answer. And again, you know you're working up on the y-axis because you're looking for the median number of visitors. And so I'm looking at these values right here. If I were to ask you like the median daily temperature, we would go this way and we'd work our way from coldest to hottest. It would still be the sixth value. So then I'd go 1, 2, 3, 4, 5, 6. So we would say the median temperature would have been about 88 degrees. So now this next one says, what is the range? So we have to approximate the highest and the lowest. So the highest point right here, the highest number of visitors is 600. The lowest, I'm just going to say maybe that's like 90. Again, when these are so spread out, like that's a difference of 75. You have a little bit of wiggle room. 600 minus 90 is going to be 510. Because I didn't really need a calculator for that. And then the last question says, what is the contextual meaning of point A? And so whenever it's asking for the contextual meaning, that's just asking you to put that point in words. So point A is right here, it's 92,450. And so basically you're analyzing the axes. So this means when the daily average temperature is 92 degrees, The beach recorded spot 450 visitors. It doesn't have to be worded exactly like that. It should be in like a complete sentence of some sort. And if I had a little bit more space, I probably wouldn't have abbreviated. But that's how you would interpret that point. Okay? And so that's scatter plots. Mainly scatter plots are used, again, when you're looking for a correlation between two different variables. Okay. The next is a dot plot. Dot plots are similar to bar graphs. They look similar. The only difference is dot plots are used for smaller data sets because each little dot represents one. So you're never going to be changing like your intervals like you could on a bar graph, where I could go up by like 5s, or I could go up by 10s if I needed to, depending on how much data I had. In this one, each dot represents one value, so you really want to make sure your data set's smaller. They're used to represent either qualitative or quantitative data. Again, it just kind of depends on what you're trying to analyze. And so if this first question says, how many families represented in the plot have 2 children? You're really just going to count the number of dots above the 2. So 1, 2, 3, 4, 5, 6, 7, 8 would be my answer. How many families in the plot have 4 or fewer? So again, not fewer than 4, 4. So I'm going to start here, or fewer. So 1, 2, 3, 4, 5, 6. 25. Sorry, there's an echo on my end, so counting out loud messes me up. And then the last one says, how many total families are represented in the plot? Well, I just found all of these, so the only ones that weren't included were the families that had 5 children, so I'm just going to add 3 to that. 28. All right, the next one is a frequency table. And again, this is kind of related to histogram as well, just without the graph. So frequency tables show the number of times a data value occurs in a set. The other difference here is that in histograms, we're looking at specific intervals. We're kind of separated into categories here. So again, 2 people have a high school degree, 7 people have a bachelor's degree, and so on and so forth. So how many total degrees are represented by the frequency table? Now, this is kind of a tricky example. This is mainly like, these are the types of degrees, so I should probably have put, like, these are the types of degrees. So when you're answering this question, I'm looking for the total here, not the number of types of degrees, the actual amount of data in our frequency table. So here I'm going to add all these together, and we're going to get 40. So the most frequently represented degree, that's just going to be the one that's listed the most, so that's going to be our MBA. And then how many degrees are at the master's level or above? So this goes in order of, like, I don't want to say highest degree, but I guess kind of. So 3 plus 4 plus 4 is going to be 11. Okay. All right, and so the other thing that we are going to do is possibly be creating our own frequency tables. And so if the number of pets, if that's what we're counting the frequencies for, I would probably start, it looks like my smallest number is 1. And then when you're making your own frequency table, you have to make sure you don't miss any values. So this one's a little bit different because we're looking at like specific types of degrees. So now here, I'm gonna have to go up 2, 3, 4, 5, and 6. And so if I'm missing any, like if no one has 3 pets, I would just put 0 here, but you would not go 1, 2, 4, 5, 6. You'll include every value once you decide where you're starting at. And so now from here, I'll just go ahead and I'll put everything where it goes. So I'm going to start with 1. So 1, 2, 3, 4, 5, 6. So 6 families recorded having 1 pet. 1, 2, 3, 4, 5, 6. 6 families also recorded having 2 pets. 1, 2, 3, 4. People recorded having 3 pets. 1, 2, and then 1 and 1. And then this next question then is just analyzing our frequency table. How many households have between 3 and 5 pets? So that's going to be here, and that would be 7 households. All right, so what we are going to end with, the last couple of trimesters is where I've seen most people I'm kind of the most confused about, and it's the stem and leaf plot. So I don't know if, like in elementary school, if these just aren't really talked about anymore. I don't know. I'd have to look that up, I guess. So stem and leaf plots are also used to show frequency of data values. So these are kind of another way to do a frequency table, but a stem and leaf plot is specifically convenient for organizing your data in order to find the mean, or not the mean, the median and the mode in a data set. All right, and so I am going to start by just kind of going through what this means. So these are called your stems. Most of the time, these will be like representative of like the tens place in a number. And if it's not, there will be like a key that tells you what it means. So sometimes you might see like this. So like 3, 0, that means 30. So again, these are the stems and these are the leaves of the number. So what this means is that if I were to list all of my data out, my data values would be 30, 30, 31, 32, 42, 49, 58, 58, 67, 67, 69, 78. Notice, just like in our frequency table, you don't skip any values. So the fact that this is blank just tells you that there's nothing in the 80 to 90 range, and our highest value is 90. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values in this data set. And so if I want to find the median, we would do kind of like what we did here. So you could either list out all your values, which would kind of go against why this is a convenient way to represent your data. And so conceptually, if there's 13 values, we want to think about what that middle value would be. So 13 divided by 2 is 6.5. So that means that my median is going to be the 7th value, because then I'll have that middle value and I'll have 6 on either side. So when I'm finding the median, this is all in order. I'm going to figure out what that 7th value is. So this would be 1, 2, 3, 4, 5, 6, 7. So that means the median would be 58 menu items. That's the 7th value. The mode, remember, is the value that appears the most. And so again, this is all in order, so you're looking for any repeats. Well, I see 2 zeros here, which means 2 30s. I see 2 58s, 2 67s. I don't have any value that repeats 3 times, so that means I'm going to have 3 modes: 30, 58, and 67. And so then this last question says, how many restaurants had between 40 and 70 menu items? And how many restaurants are being represented? Well, we already answered that question, 13. So between 40 and 70. So 78 is going to be too high. So I'm going to look in that little section right here. So 1, 2, 3, 4, 5, 6, 7. So again, these stems represent the place values. Normally is going to be the 10. And then this is the second part of that number. So I'm going to post a couple extra practice problems in tomorrow's agenda when you're reviewing to help you with that if you still need a little bit of help. But your homework tonight is posted on Canvas. Just let me know if you guys have any questions.